Good morning, everybody. Welcome back to lecture number 43. Today we talk about the power converters. From its name, power converters, what do we convert? Power. So let me give you a simple example. Do you remember in E213 the H-bridge rectifier? Not the H-bridge, the three-guide rectifier. I think it's something like that. كده or something like that. And here you apply a sinusoidal, and here what do you get? Rectified signal. Remember this? If you connect a load here, this voltage will be applied to the load. صح? Without this rectifier, if you connect directly sinusoidal signal على resistor, what is the average power? Zero. Why? Because it's a sinusoidal signal. But what is the average power here? Somewhere halfway maybe. Plus or minus. So here, did we convert using this the power at the load from the source? Yes. So this is the basic idea. You change the shape of the signal in order for you to get different power at the load. You change the shape of your output signal in order to have different power delivered to your load. Because in the AC power systems, the average power of a sinusoidal signal is zero. This is very common. Do you have a charger? So currently, we have a charger here. So what is the average power here? Zero. Sinusoidal. Here we have what inside the iPhone charger? A rectifier. So here we get a power to the iPhone that is not zero. Okay? So this is nothing but a rectifier circuit. So did we convert the power?
Yes.
Yes, we did convert the power. So the moment you use diodes, transistors, MOSFET, or any power electronics 203, 303 devices, you change the power, the nature of the signal. Power system is electric circuits. It still needs power electronics. For example, if we have power, if we have solar plant, what is the output of solar farm? DC ولا AC? خلايا الشمسية. When the solar cell goes exposed to the light,
DC.
what is the output voltage?
Output. DC.
It is DC. How can you integrate this with the electric grid? You need to convert it from DC to AC. So this is what we call the inverter. Let me tell you one good thing to buy in life. All of you have phone chargers in your car. You either have USB or USB Type-C, صح? You extend this to the cable, you charge your phone. Maybe the Type-C is faster to charge, but both of them, they're not better than if you connect it to the electric outlet directly, صح ولا لا?
Yes.
The reason is here you get the power from the power that you get from the car. It was from the 12 volt DC to the DC power system, so you don't have AC. But if you have the power from the electric socket, you buy, let's say, inverter, small inverter, then you connect your electricity, you connect, طبعا هي طفاية الحريق، طفاية الحريق. You put inverter وتشبك عليها الكهرباء. Your iPhone will charge as if it was plugged to the wall. You have Amazon?
يعني دكتور تقصد انت الشاحن هذا الشاحن اللي يطلق كذلك؟
Yes. My point is if you لو وصلت طفاية الحريق, you connect inverter, DC will become AC, then you can charge fast.
افضل من اشبك السلك احطه
في الطفاية الحريق، طفاية الدخان. ولا وأفضل من توصلها بيو اس بي ويو اس بي سي. هذا بطيء بطيء بطيء، بس إذا خليت انفرتر يصير كأنه كهرباء عادي.
ليش نشتري فوق؟
Inverter. Try it. It's a very good investment. Okay. Some cars are equipped with AC power. I think a Jeep. The Jeep they are already equipped with. Land Cruiser maybe.
دكتور هنا الدي سي الاي سي انفرتر.
Yeah. This is DC to AC. You connect inverter. Same with the solar. You connect DC to AC. Now you get AC. You treat it as an AC output.
بسألني سؤال، شو هو الشيء المفضل بالنسبة لنا اللي يكون دي سي بدل الاي سي؟
No. My point is the iPhone charger that's based on AC system is faster than the cable that you connect to USB. USB يطول لما يشحن. لأنه بيشغل كهرباء يطول.
بس مو اصلا الايفون شارجر فيه اي سي لدي سي كونفرتر.
Yes, but because you're using AC power. It's AC power. The rectification process makes you capable to deliver more current.
دكتور لما تيجي تتحول من دي سي لاي سي وترجع تحول لدي سي الافرج بيقل؟
It depends what do you want. The power, you have losses. The average power is voltage times current. If the average voltage is zero like this, then the power is zero. I'm not telling you AC is better than DC. Again, war of currents. Do you remember war of currents?
Yes.
It's the same argument. My point here is having this flexibility to convert from AC to DC gives you certain advantages. Faster charging. The power is the same. It's just faster charging. To you, if you have a car that doesn't have AC outlet, buy an inverter, try charging your phone. It will be like charging it from the wall. So from DC to AC is inverter. From DC to DC is, we call it chopper. From AC to DC, we call it rectifier. The last one, from AC to AC, we call it regulator. Okay? We'll talk about it. So, Module 8 talks about power converters. We convert the power itself. The interdisciplinary nature. So what is the power converters? Why it is special? It is special because it combines power, EE360, electronics, 203 and 303, and control, 380. If you combine all the three, you deal with power electronics. So what is power? we have static or rotating power devices, transformer, synchronous generator, transmission line, is static. Induction motor, rotating. Or electronics, we have devices, diode, transistor, or circuits. Rectifier circuit. Control, we have continuous or discrete. Discontinuous, continuous control signal, or discrete, pulses. So combining all the three, what do we have? We have the power electronics. I might bring this triangle in the exam. And I tell you, fill it with EE courses. So here you have to put EE360. Here you have to put EE203, EE303. Here you put 380. So that's why I'm telling you, you have to take 380. You have to take 303 in order to get senior level courses in power. One of them usually is a prerequisite, along with the E360. Not always. So what's the definition of power electronics? It is the application of solid state. Solid state ايش معناته؟ Solid state from the physics. Semiconductor devices for the control and conversion of electric power. We control the power and we convert it. So power electronics is the application of solid state devices, اللي هي transistor, BGT, thyristor, we'll talk about them. Triac. It's the application of these devices for the control and conversion of power. We convert the power. Here average power is 0, here average power is non-zero. So power electronics is very important in the technology. It's used in high power product like heaters, with light controllers, with electric motor control, how we control the induction motor, how we control DC motor. You need power electronics. Power supplies, to improve the quality of power supplies. Vehicle propulsion system, like an electric vehicle, how we control the speed of electric vehicle. We need to have inverters, we need to have DC links, we need to have multiple things. Renewable energy. If we have solar cells, we need to have inverters. Let me ask you a question. What is a wind? Is it the output of the wind turbine? Is it AC voltage or DC voltage?
AC.
AC. Why? Because it's an induction generator. Is it synchronous? No. Why? Because there is no mechanical engineer that tells the wind to spin at a certain speed. So we use induction generator. Why? Because we have the slip. But now it's the same induction motor, but you drive it as a generator. What's the output? It's AC. So can you get AC to AC directly 60 Hertz? No. Actually, this box has AC, then we have DC to DC, then we have DC to AC. It's very compact, but we call it AC to AC. Because you don't get 60 Hertz. Do you get 60 Hertz? For the wind, no guarantee. Do you get high voltage? No guarantee. So you want to put it in the standard grid, maybe for 80 volts, 60 Hertz. You have to control the voltage and the frequency. So this device has very complicated things inside. Okay? Same thing for inverter. Is it just rectifier? No, there is other things. Filters, circuits, bypass, low pass. Same for DC chopper. We have capacitors, we have complicated things. Same thing for a rectifier. Is this DC? No. If we add a smoothing capacitor, it will be almost DC. But the basic concept is the rectification process. So we have high voltage DC. What is high voltage DC? It's transmission lines, but instead of AC, you do what? DC. And what is the requirement? You really need to have AC to DC, and then DC to AC, because the line is DC, the grid is AC. So you have AC to DC, line is DC, DC to AC. So it's complicated. You need two power electronics. So what are the devices, the switching devices? We have uncontrolled turn on and off, like the power diode. You don't control the diode. If the voltage is above the threshold, in E203, what was the threshold? 0.7. For the power diode, this voltage is higher. Maybe 10 volts, maybe 20 volts. So it's bigger. Controlled turn on, uncontrolled turn off. Thyristor. Thyristor is a diode, but you can control when it turns on. For example, how does the diode look like? This one, right? No, this one. If you add a gate, if you apply this is A, this is B. If VAB is above V threshold, it will not turn on. But if you send a pulse, it will turn on and stay on until VBE less than V threshold. Then it will turn off. So we control the on, but we cannot control the off. In diode, if you apply above 0.7, it will be on, short circuit. If it's below 0.7, it will be off. At the gate, it will not be on until the pulse is sent and the VAB above the threshold. It will remain on until VAB goes below the threshold, then it will be open circuit. This is the thyristor. Is it the first time you hear about the thyristor? Did you hear about it? We have controlled turn on and off like a transistor. If the VBE حق transistor is above the limit, the transistor will conduct forward bias. BGT, MOSFET, GTO, IGBT. So we have control on and off. We can control it. We have either continuous gate signal requirement, like in BGT with MOSFET with IGBT, or we have pulse gate requirement, silicon controlled rectifier, or GTO. We have bidirectional current capability, like the TRIAC. TRIAC is actually one diode here, one diode here, and then you have a gate. So you send the gate to conduct either of the two directions. كأنها two parallel diodes. So we have bidirectional current capability. We can transfer current from this way to this way, or from this way to that way. Or we have unidirectional current capability, like most of the power electronics. Unidirectional. The diode is unidirectional. Transistor is unidirectional. TRIAC is bidirectional. So this is a summary of how they operate, or how we classify them. We classify them based on control, based on the type of the pulse, or based on the direction of the current. The only two new devices that you have is three devices: SCR, thyristor, triac. And all other devices are in TO3 and TO3.
GTO.
It's similar to a transistor, but it's maybe it's similar to an IGBT.
ما أخذنا
أخذته؟ Okay, we will not dig deep into them. As long as you know the name, you know the general purpose, it should be fine. To me, all the transistors are the same. If the gate voltage is on, it will conduct forward bias. Let's look at some of the. Okay, time is off, right? So if you look at the history, we have vacuum tube, rectifier, thyratron, obsolete, we don't use it anymore. Mercury amp rectifier, those are before the 60s. Then the thyristor was invented, which is the diode with a gate. We have the power diode thyristor. Then in the 70s, what happened in the 70s? The transistor was invented. They say it's the most important invention. But to me, the most important invention in electrical engineering is the induction machine. I don't think it's the transistor. So the two most important inventions in electrical engineering are the transistors and the induction machine. Not the synchronous, not the DC, the induction machine.
Tesla.
That's my opinion.
عشان كذا جبت عن الور كانت.
But it has nothing to do with war. But to me, the transistor is also important because it's used in computers. To me, I think the induction machine is more useful. Then after the 70s, we have the microprocessor, thyristor, power MOSFET, GTR, GTO. In the 80s, we have DSP, digital signal processing. We have thyristor, power MOSFET, IGBT. Those are now the ones used. Look at this figure. Between 2005 and 2020, we improved the voltage level from 1 kV to 5 kV to now 10 kV. So we increased the voltage level of the power electronics. Not only that, from 10 watt per centimeter cube, 25 watt per centimeter cube, up to 50 watt per centimeter cube. So we transfer more power. So what are the applications? Here we have home application, lighting, inverter, power unit for IT, power conditioner. Here we have electric vehicle, electric trains. Here we have power transmission system because we have distribution system. Also the wafer size, which is the size of the semiconductor chip, is getting bigger. Here we have 8-inch, 6-inch, 4-inch. It's getting bigger to withstand higher voltage. So this is a very hot topic, power electronics. Power electronics is very hot topic. So we will continue next lecture, but we forgot that.
دكتور الباور الكترونكس يعني هل له سوق عمل عالي؟
الحمد لله.
عليه طلب عالي؟
Everything has كل شيء عليه طلب.
الحمد لله.
There is nothing. There's something is wrong.
صح يحتاج يكون معنا وين الصوت مو هو شيء مو أي شيء مو زي مثلا يقول لك رئيس يسر ما أعتقد شيء أصلا
What's the last lecture?
حز كان عنده حز
وش كان التاريخ؟ 7 6 5 4 أبو عابد
7
أبو عابد الجرين العنزي
موجود
Stop the recording. Sorry.